In today's lesson, we're going to deal with complex numbers in which there is a numerator and a denominator in both the numerator and the denominator. So basically it's multiplying or dividing a rational expression by another rational expression. Let's look at this lesson opener. We're going to write this as a fraction over a fraction. And it looks kind of jumbled whenever you first look at it, but this is our first fraction divided by this fraction. As we know, whenever we're dividing fractions, we can multiply by the reciprocal. So what we do is we turn the second one around and use the reciprocal and multiply. We multiply straight across. We can reduce though before we actually multiply. And then we end up with 9 over 2 and we leave that how it is. This time we're supposed to write this as a mixed number. So whenever we look at 9 over 2, it's the same as 4.5. And whenever we look at the sum of a whole number and a fraction, it's 4 plus 1/2. So let's look at mixed rational expressions. So the sum of a polynomial and a rational expression is a mixed rational expression. We did some of these earlier. We did the lesson before where we have to find a common denominator. We think of 4y as being over 1 and we find a common denominator. In this case, it would be y minus 2. And we multiply the top and the bottom by the same number to create equivalent fractions. And then we go ahead and combine with our common denominator in the bottom. So whenever we're dealing with a complex rational expression, we're dealing with an expression that has a numerator and a denominator in which both of them are rational expressions. Sometimes that looks like a whole number, sometimes it looks like a fraction. Whole numbers and fractions are both rational expressions. When we have a rational expression that has fractions in the numerator and the denominator, we need to first simplify them. For instance, we have x over y divided by 4. And we can think of this a couple different ways, but whenever we divide by any number, this is 4 over 1, and we think of it as whenever we multiply, it's 1 over 4, so we have x over 4y. Okay, so this one has a little bit more to it. It's x plus 2 over x squared divided by x plus 2 over x. So one method of solving this, there are a couple different ways of solving it, but the main one we're going to focus on here is to simply use the reciprocal of the second expression and multiply. We know how to multiply x plus 2 times x and x squared times x plus 2. We can cross-reduce, just like if we had 2 over 3 and 1 over 4, and we could reduce this to 2 and we could reduce this to 1. The same is true with rational expressions. If they're the same, we can reduce them. And then our x's can reduce and we have 1x left over. We do not have anything left in our numerator, so that makes it be a 1. So we're left with 1 over x. Now we have no more reducing to do. So like I said, there are two ways of simplifying complex rational expressions. one way is to multiply by the reciprocal. The other way is to multiply the numerators by the common denominator. So let's look, we're going to look at actually both ways. So we're going to do this problem using the first method, in which you multiply by the reciprocal of the second number. And you can reduce as you're able, and you can also, if we split this up, you can see that our 4x will reduce, our x plus 3 will also reduce. So when both of our denominators reduce, we're just left with the numerator, because it's the numerator over 1, and anything over 1 is just the number. So we have x minus 3 times 2x, and we can go ahead and distribute that and make it 2x squared minus 6x, and that's as simplified as it gets. Now when we look at that same problem using the second method, we're going to multiply by our common denominator. Our common denominator in this case is 8x squared. Now remember, when we multiply, we're saying 8x squared over 1. So we're actually multiplying this stuff. And it looks like this. Now, whenever we multiplied this 8x squared, they canceled out. So all we were left with was the x plus 3. Here, this cancels out and we're left with 2x here. So that's why we have x squared minus 9 times 2x. And then you can actually factor out the x squared minus 9, and notice we have an x plus 3 and an x plus 3. We can go ahead and cancel those out, and we're left with 2x times x minus 3, and we can go ahead and distribute that 2x, and we come up with the same answer that we had before, 2x squared minus 6x. You're going to get the same answer regardless, but you might find that you prefer one method over the other, or you may use one method for some problems and one method for other problems. Whichever one works for you is fine. So let's look at another example. For this one, method 2 is going to be easier, so let's look at that. So then if we go ahead and factor some of this out, it makes it just a little cleaner looking. And here's your homework. Go ahead and get started.